Hey everyone, welcome back to the lab. In this video, we're going to be doing an intro to Pts.js, a visualization library, through an example of building a flashing square. So a little background on why we're doing this. Last week, I released timetick.xyz, which is a little bit of a visualization of passing time. And if we go to the site, we can kind of see what it does. We can see it loads a little web page, and then it has this little flashing red square. And I wanted this because I thought it was like kind of like a clock, and every second you see this like thing ticking. And it kind of is a better visualization of the passing of time, like a visual representation and kind of reminder of that. Now, at the same time, I've also been kind of exploring some different visualization libraries, trying to get a little bit away from the more imperative coding styles that I've kind of used in the past with things like Pts.js processing, even some of the game libraries like Unity and Godot, because I think there's a better way, but I just haven't seen it yet. And so when I was doing research for this, I kind of came across Pts.js, which is this kind of declarative visualization library that allows you to kind of write in more functional approach and gives you these very interesting primitives to play with. And I was pretty happy with it in this project, so I thought I'd share a little bit about how I built it. So this is Pts.js. You can read more about it at pts.js.org, and the rest of this will be a little bit of an intro. And so what we're going to be doing in this video is really trying to understand how can we build this flashing square with Pts.js. And the idea is by the end of this, we should have a generalized approach to kind of time-based dynamism. So allowing our sketch to kind of change with time. How do we hook into that time thing and do something with it? And so to do this, we're building that flashing red square, stripping away everything we don't need and just kind of focusing on this one thing that changes. And I'm going to be showing you a demo of this using Pts.js's playground. Basically, it just gives you a simple coding environment that already imports the library for you. I'd really recommend this for playing around with the library. And all the code is available on my website linked here, and we'll walk through it later. But if you want to copy and paste it, this is how to do it. And so here we have the sketch running in that little playground, and we can see that it just flashes from white and black to red. And here's the code, which we'll go over in a minute, but just to prove to you that it's working and kind of give you an idea of what we're actually going to go over here. And so in the rest of this video, what we're going to do is dive into kind of how this works, and hopefully give you the basic concepts to understand Pts.js and start playing around with it yourself. So the first thing we're going to do is a solution overview, just to give you a framework for what exactly this thing is doing. Then I'm going to go into a few important concepts that I think are interesting from Pts.js that might be a little bit different from a lot of other graphical libraries that at least I've used. And then we'll dive directly into the code, and hopefully it'll make a lot more sense after we've done this. All right, so first solution overview. This is basically the pseudocode. Like no matter what language we have or what library we're using, we're basically got to do these things to make a flashing red square. First thing we got to do is create a rectangle that's symmetrical, so it is actually a square. And then every second, what we're going to be doing is incrementing a color counter. Now there's a lot of ways to hold state, but I think a counter in this case is pretty easy, pretty simple. And basically what we're going to do is if every second it's incrementing, we just check if that color counter is even. If it's even, we're going to color the thing red. If it's odd, then we're going to color it white with black borders. And that's how we're going to get a flashing square that flashes every second. And so this is the basic framework of what we're actually trying to code. And now let's dive into some important concepts or some interesting things in Pts.js that I think you should know as you start to play around with it. So the first thing that I think is really cool and interesting is this idea of tempo. And basically what it allows you to do is create a time-based execution hook described as BPM or a beats per minute. And I think it's important to maybe call out how this is different from a lot of other libraries. So, basically everything 3.js, P5.js, Unity, Godot, it will have like an animation loop, an update loop, if you will, that as fast as the framework or runtime can, it's going to call this thing with a delta of time to say like, hey, go render. And this is how you're getting like your 30 FPS, etc. It's going to be running as fast as it can, and you're going to be updating the state based on it. Now that's fine, but to actually make something that's synchronized over time, like let's say 1 second intervals, you basically have to build out a little structure on top of it to basically say, hey, the whole solution started at this time, and then now the current frame rate is this time, and now you got to do some little differentials to basically understand how much time has passed. If it's a 1 second, do you need to toggle it? And then you kind of build this like whole time-based thing yourself. And that's fine, and it works in every language, and so it's good to know that. But I think it's really interesting that Pts.js is really trying to build these primitives that make declarative code a lot easier. And tempo is just one great example of doing that. And so here's the basic usage. Basically, we're creating a tempo. It takes in BPM, beats per minute. It's taken from like the audio music kind of land where we can describe our own framework of time within the actual framework of time. And so here's 60 BPM, which again would mean that it would run once per second. And then what we can basically do is based on this tempo, this basically provides an easy way for us to synchronize all the things we have. And so we have a 60 BPM run tempo here, and we can say for every n amount of beats, we want to do something and kind of run arbitrary code. Here, I'm just console.logging out the count here, which I believe is the count of total beats that's happened so far. But you can imagine that you could maybe update state here, or I don't know, do something more interesting, evolve the sketch, stuff like that. And this is what we're actually using in our sketch to actually update that counter, update the state to change the. But I think this is very interesting. There's a lot more that I think you could do with this, but really, really cool part of Points.js here. If you want to learn more about this, you can check out the official guide. Animations got a lot more stuff in there, but really cool here. Okay, the next thing that I think is important to understand about points is its idea of space and form. It really kind of abstracts a lot of this stuff, but basically what it's saying with these forms is that everything that you have is really just a group of, and this is true in the 2D realm for what we're doing here. It might not totally be true, I'd say, maybe for more complex or different kinds of things like video games. This might not be a great abstraction, but I think for a lot of generative art and things that are in a 2D plane, this is a very interesting abstraction where every shape you have can just be described as points. And so playing with the primitive points allows you to basically create shapes, project it onto the points plane, but then now you just have a collection of points that actually could be represented by many different shapes or could be representative of many different kinds of shapes, which is a very interesting thing to play around with in the form of like potential possibilities, the opportunity space to play with. And so the main tenets here is that everything is made of points and a shape is just a group of points. And so for us, we just want to build a simple rectangle. And so there are some simple like common helper functions like rectangle, circle, stuff like that, that helps you create these points in a form that makes sense from the shape, but it still gives you the flexibility of just having those kind of primitives that you can play around with. And so here to create a rectangle, all we're doing is rectangle.from. We're giving it a place to start with, the size that we want of the rectangle, and this is just going to return us an array of points, a group of points, if you will, that describes this rectangle. In this case, I believe it's the top left corner and the bottom right. Now, for a full list of all these kind of like higher level operations to kind of work on points, you can check out the op guide. They call it ops, and there's a few more in here that you can look. Okay, and the last important thing I kind of want to touch on in points I think is different and very interesting is the idea that when we're drawing things, we're not drawing these shapes. What we're actually drawing is points and the connections that we are defining. And the guide has an interesting kind of metaphor for this where they're basically saying like the reason this is so powerful and generalizable is like if you look at stars and how we have like our own versions of constellations that we can draw shapes from, but actually those same stars can actually mean many different kinds of constellations. We can draw like infinite different connections between these things, even though the points themselves are the same. And this is a really interesting design choice that leads to quite a lot of generalization. And so here what we have is basically the simplest kind of drawing points to space. If we're thinking of this in terms of basic shapes, we provide a stroke as we'd expect, a fill that we'd expect, but then we have to say, how do we connect these points that we're about to give you that we want you to draw? There's a helper here for polygon. We're going to give it a polygon and then we're going to describe the polygon. And so we're just giving it that group of points and we're saying, hey, this is a rectangle and these are its corners. And that's how it knows how to draw. But you could imagine that if we didn't do this, maybe it would want to draw just a line, or we could provide our own kind of higher level functions to describe different connections, ways of connecting these points, which gives a lot of power and generalization to just like a few lines of code, which I think is really cool. Even though right now we're just using it for like its, most basic way of drawing. Okay. And that's basically everything we need to really understand this code. So now let's go back to the demo that I showed you earlier and we'll just walk through the code line by line to really make sure that it's understandable. Okay, so I'm back here in the Points.js playground, and this is just the copy and pasted code from my blog post. And like if you're actually writing this in your own website, you need to do imports or whatever, but we're in the playground, it already has this stuff imported. And so all we do is have this function, and it's basically a main function that just runs down. So we're going to set up a few things. We're going to do the points quick start, which is going to set some global variables for us, the space and form. These aren't hard to add yourself, but it is nice that it kind of takes care of this. Here I'm just going to set a const, which is just the size of the rectangle. I made it kind of big so it's easier to see. And then here we're setting up our 1 second tempo. It's a 1 second tempo again because we're giving it 60 BPM, which just comes out to 1 second. But if you wanted to make it go faster or something, you could. And now we're just kind of hooking into our 1 second we want to change something. And so what we're doing is, hey, on the 1 second tempo for every one beat at 60 BPM, so it's just 1 second. So every 1 second we want to do something, and we call this, and all we're saying is, hey, color counter. We're going to set it to the count. This increases for every count. I believe this is the count that the tempo has run. And so this is basically the same as color counter plus plus, but we're just using the count because it's past tense. The next thing we got to do is we actually have to add our tempo to the space. And if you've used Three.js or a node-based system, maybe like Godot, you should understand kind of how this works. Basically, every sketch, if you will, has like a root node. And then if you want anything to execute, it needs to be connected to that node because it's going to go down the children and execute each of those. And so this is how we're doing it by adding it to our space so that it knows that on animate, oh, we should actually make sure that that tempo is clicking along. And now we have this run function. And this is basically the same as like an animate loop or an update loop and maybe one of those game engines like Godot or Unity. And so this is going to run as fast as it can, and it's going to pass in a few things time. And I believe this is the same as delta time here that make it easier to see like how far we've gone between frames that we want to run. And so here we're just going to create our rectangle. Here we're just setting it in the center. We're giving it the size, and this is again going to pass us back that array, that group, if you will, of points that describe the rectangle. And then we're just going to check our color counter. We're going to say, hey, if it's even, then we want you to draw U red, and if it's odd, then we want you to draw white fill with black stroke, so black background, or sorry, border. And that's it. A quick intro to Points.js and a little bit of example code to get you started. Thanks for watching, and I will see you in the next one.